Hello students, welcome back. So now we are going to be focusing our attention on histogram plot. Histogram plot, they look like this. This is how the visual image of a histogram plot is. Generally use histogram plot when you want to understand how your numerical data is distributed. So first thing I'm doing, importing my Seaborn library. I'm also importing my matplotlib library. In this particular instance, I'm actually reading tips dataset. I'll be looking at tips dataset. So I print out the few records of tips dataset, and it tells you like you have total bill, tip, sex, smoker, date, time, size, and I'll be actually focusing on this total bill right here. So in this case, people they go to restaurant, they pay the amount, and this is that the column is. So I want to look at the stats. I want to look at the descriptive stats of the total bill. So it tells me there are total 244 records. The average value of total bill is 19.78. The minimum value is 3.07 and the maximum value is 50.8. That means my total bill, it ranges from 3.07 and goes up to a 50.81. And then it tells me the 25th percentile, also tells me the 50th percentile and 75th percentile. Also tells me the standard deviation of my total bill. Now let's visualize the distribution of the total bill. So in this case, I'm calling histogram plot. I'm specifying my data equal to tips and specifying the name of the column that will be total bills, and I'm doing plt.show, and this is how it looks like. Let me decrease the size of the screen. It's a little bit more visible. Okay, and you can see that most of my total bill, it goes from here, which I would say between 10 to up to maybe 25 or 26, and you can see the minimum value goes from here to up to here. If you recall, when we looked at the values over here, the minimum value was 3.07 and the maximum value is 50.81. So it does go from 3 all the way to 50. All right, and now let's look at the distribution of the total bill. In this instance, I want to put them on the y-axis. Over here, I was doing along x-axis, but what if you want to change to y-axis? You can do that too. In this case, all you have to do is say y equal to total bill. That's all. And now you can see your distribution plot is being done on y-axis. So you can switch axis depending on your need or your desire. Okay, now let's say you want to take out the list distribution plot, and you also want to do the KDE. KDE stands for kernel density estimation curve. You also want to look at that. In this case, all you have to do is just say KDE equal to true. By default, KDE equal to false. That's why I did not plot it before. All right, so when I plot this, you can see that now it actually draws a little smooth curve that kind of gives you an idea how your distribution is, like how the curve is basically going. And you can see it's kind of like a little bit right skewed, is skewed towards the right. Okay, so this is your distribution plot. So a few observation you can make from here. Number one, oops, most people in this data set, they spend between 10 and 20 on their meals. So you can see that most of the people, like right here, between 10 to 20. Most of my data is over here between 10 and 20. You can see that by looking at the graph. A few people spent a lot more, maybe up to $50. And you can see that like there were some few people, not a lot, but some of them spent a lot of money, 50 bucks. And that's because you see this right here. So anytime when you see the curve, anytime when you see a bar like this, a plot like this, which is a little bit higher than the rest of them, so basically, that should tell you that there were some people who spent a little bit more money over here. And that also is indication. You can also determine that by looking at the KDE curve that will go slightly extending on the right hand side. Okay, and so in this case, the distribution is skewed to the right. You can see that the distribution goes like this, and then it kind of like skews towards the right. So that's because of this presence of this right here. Now, histogram plot also has a parameter called bin width and bin range. This gives you a little bit more fine control over your histogram plot. So in this case, I'm specifying my bin width equal to 2 and my bin range equal to 5 comma 50. What it does, it plots your histogram plot, and you can see that each one of the bin width now is 2. Each one of them is 2 over here, and also is going from 5 all the way up to 50 over here. That's because I specified my range as 5 comma 50. Let's say I change my bin width from 2 to let's say 4, and I change my bin range, let's say from 10 to 50. So let's read on this again, and you can see that now the bin width is 4. Each one of them is 4 bin width. From here to here is 4, 4, 4, and it's going from 10 all the way up to 50. If you go back and change back to its original form, which is bin range is from 5 to 50, and bin width is 2, rerun this again, and now you're going to come back to its original form. You can see that bin width is 2, and ranges from 5 to 50. Now, histogram plot, you can also separate by categories. You can actually draw this different distribution of data, numerical data based on the category. So in this tips data set, I have a column called sex column. So in this case, for male and female, I want to know the distribution of both of them separately. So in this case, I specify my u equal to sex right here. Okay, and I'm also doing my kd equal to true. So this way I get to see my curve. So when I plot this, you can see that this is how it looks like. The blue one, that would be this, that represents your male. So this is your male, and this one right here is your female. Okay, so a few observation you can make. Number one is that more men they give tip than females. Well, that is because if you look at this curve right here, it's a little bit higher than this curve. So that tells me that the men they tend to be little. You have more men giving tips. Okay, that's what it basically is telling you. It's not telling you that more tip the amount of tip is given by men is more. All it's telling you is that the count of tip that is given by men is more. Then also that's because you have more area under the KDE for men. That's another, that's you can draw this conclusion also by looking at the area. Okay, the amount of tip given by male and females are almost the same. So the amount, the money that somebody gives for tips is pretty much the same, but the number of tip that was given by males is higher. That's what this is telling you. Let's look at this one iris data set. So in this case, I load my iris data set and I plot this. Sorry, I just print out a few records right here, and then I'm just doing histogram plot of my petal length right here. So you can see that histogram plot for petal length will look something like this. Okay, so you have petal length, so it goes up, then it comes down, then it goes up. Okay, so there is some separation over here. Let's see what's going on. So in this case, data equal to iris, my x equal to petal length, and in this case I'm using my u equal to species. So there are three different types of species in your iris. Is a setosa, versicolor, and virginica. So I want to separate all these three data set, and I want to draw the histogram plot for all these three. Okay, so when I draw this, you can see the graph looks like this. This is pretty interesting. Now this particular graph right here tells me, this particular plot tells me one thing, that setosa, that would be this one, the bluish color, that would be this right here. Setosa has petal length between 1 and 2.5. So you can see that from 1 to 2.5, that's where the sepal length is, sorry, the petal length is of Setosa. All right, and so we can easily identify this species just by looking at petal length. So if you see any plant and if you are able to see the petal length is between 1 and 2.5, you can safely conclude that it is a Setosa. You can identify that. The versicolor and virginica has little overlapping. You can see that this is your virginica and versicolor, which will be this and this color. So you can see that this one and this one, there is some overlapping. This is happening right here. And the versicolor has a petal length from 2.5 to 5.5. So you can verify that. Like if you look at this one right here, this is actually going from 2.5 and going up to like 5.5. All right. So this will be your versicolor. Likewise, you can make the similar conclusion for this one. That would be your virginica. Virginica goes from, I would say, from 4 to maybe like 7. So this way you can actually, yeah, there you go. So you can draw these types of inferences by looking at these curves. Another interesting thing is that the amount of area in the KDE is almost similar for three species, although this may not be very obvious for this one. But if you look at the area under this curve and the area under this one right here, you can identify the area under this curve is pretty much similar to the area under this curve. That should tell you that the number of species for your versicolor and virginica is pretty much same. That's why the area is same. By the way, the area of this is also like, if you're really good at visual, you should be able to tell that the area of this is similar to the area of this, and that's because the count, okay, the number of setosa is same as the number of versicolor and virginica. By the way, I already know this thing because I've seen the count of each one of them. Okay, I hope this session helps. Thank you.